Welcome back. It's Chapter 7, Transmission Lines. There are 59 questions in this chapter. Number 1. The unit decibel is used to indicate a mathematical ratio. Number 2. A 2-time increase in power results in a change of how many dB? 3 dB higher. Number 3. A local amateur reports that your 100-watt 2-meter simplex VHF transmission as 30 dB over S9. To reduce your signal to S9, you would reduce your power to watts. 100 megawatts. Number 4. How can you decrease your transmitter power by 3 dB? Divide your original power by 2. Number 5. How can you increase your transmitter power by 6 dB? Multiply the original power by 4. Number 6. If the frequency is increased, how would this affect the loss on a transmission line? It would increase. Number 7. What factors determine the characteristic impedance of a coaxial antenna feed line? The ratio of the diameter of the inner conductor to the diameter of the braid. Number 8. What is a parallel conductor feed line? 2 wires side by side held apart by insulating rods. Number 9. A transmission line differs from an ordinary circuit or network in communications or signaling devices in one very important way. That important aspect is propagation delay. Number 10. The characteristic impedance of a parallel wire transmission line does not depend on the velocity of energy on the line. Number 11. The characteristic impedance of a 20-meter piece of transmission line is 52 ohms. If 10 meters were cut off, the impedance would be 52 ohms. Number 12. The characteristic impedance of a transmission line is equal to the pure resistance which, if connected to the end of the line, will absorb all the power arriving along with it. Number 13. The characteristic impedance of a transmission line is determined by the physical dimensions and relative positions of the conductors. Number 14. What factors determine the characteristic impedance of a parallel conductor antenna feed line? The distance between the centers of the conductors and the radius of the conductors. Number 15. The impedance of a coaxial line can be the same for different diameter line. Number 16. What is a coaxial cable? A center wire inside an insulating material which is covered by a metal sleeve or shield. Number 17. What commonly available antenna feed line can be buried directly in the ground for some distance without adverse effects? Coax cable. Number 18. What connects your transceiver to your antenna? A feed line. Number 19. Where would you install a balun to feed a dipole antenna with 50 ohm coax cable? Between the coax cable and the antenna. Number 20. What kind of antenna feed line is made of conductors held apart by insulated rods? An open conductor ladder line. Number 21. What commonly available antenna feed line can be buried directly in the ground for some distance without adverse effects? Coax cable. Number 22. What does the term balun mean? balanced to unbalanced. Number 23. If the length of a coax feed line is increased from 20 meters, or 65.6 feet, to 40 meters, or 131.2 feet, how would this affect the line loss? It would be increased by 100%. Number 24. What is an unbalanced line? Feed line with one conductor connected to the ground. Number 25. As the length of a feed line is changed, what happens to the signal loss? Signal loss increases as the length increases. Number 26. What is the best antenna feed line to use if it must be put near grounded metal objects? Coax cable. Number 27. The lowest lost feed line on HF is open wire. Number 28. Why does coax cable make a good antenna transmission line? It is waterproof and its impedance matches most amateur antennas. Number 29. A 75 ohm transmission line could be matched to the 300 ohm feed point of an antenna by using a 4-to-1 impedance transformer or balun. Number 30. Why should you use only good quality coax cable and conductors for a UHF antenna system? To keep the RF loss low. Number 31. If your transmitter and antenna are 15 meters apart, but are connected by 65 meters of RG58 coax cable, what should be done to reduce the feed line loss? Shorten the access cable. Number 32. If you install a 6-meter Yagi antenna on a tower 50 meters from your transmitter, which of the following feed lines is the best? RG213. Number 33. When antenna feed lines must be placed near grounded metal objects, which of the following feed lines should be used? Coax cable. Number 34. Losses occurring on a transmission line between transmitter and antenna result in less RF power being radiated. Number 35. Why should you regularly clean, tighten, and resolder all antenna connectors? To help keep their resistance at a minimum. Number 36. A balanced transmission line is made of 2 parallel wires. Number 37. TV twin lead feed lines can be used for a feed line in an amateur station. The impedance of this line is approximately 300 ohms. Number 38. What common connector usually joins RG213 coax cable to an HF transceiver? A PL259 connector. Number 39. A flexible coax line contains braid and insulation around the center conductor. Number 40. In what values are RF feed line losses expressed? dB per unit length. Number 41. What common connector usually joins a handheld transceiver to its antenna? A BNC connector. Number 42. What are some reasons to use parallel conductor feed lines? It will operate with a high SWR and has less loss than coax cable. Number 43. What are some reasons not to use parallel conductor feed line? It does not work well when tied down to metal objects, and you must use an impedance matching device with your transceiver. Number 44. Which of these common connectors has the lowest loss at UHF? A type N connector. 45. What kind of antenna transmission line can be constructed using two conductors which are maintained a uniform distance apart using insulated spreaders? 600 ohm open wire. Number 46. What device can be installed to a feed balanced? Number 46. What device can be installed to feed a balanced antenna with an unbalanced feed line? A balun. Number 47. As the frequency of a signal is changed, what happens to signal loss in a feed line? Signal loss increases with increasing frequency. Number 48. If the impedance terminating a transmission line differs significantly from the characteristic impedance of the line, what will be observed at the input of the line? Some value of impedance influenced by line length. Number 49. What does an SWR reading of 1:1 mean? Best impedance match has been made. Number 50. What does an SWR reading of less than 1.5 to 1 mean? A fairly good impedance match. Number 51. What does standing wave radio mean? Number 51. What does standing wave ratio mean? The ratio of maximum to minimum voltages on a transmission line. Number 52. If your antenna transmission line gets hot when you are transmitting, what might this mean? The SWR may be too high or the transmission line loss may be too high. Number 53. If the characteristic impedance of the feed line does not match the antenna input impedance, then standing waves are produced in the feed line. Number 54. The result of the presence of standing waves on a transmission line is reduced transfer of RF energy to the antenna. Number 55. An SW meter measures the degree of match between transmission line and antenna by comparing the forward and reflected voltage. Number 56. A resonant antenna having a feed point impedance of 200 ohms is connected to a transmission line and transmitted which has an impedance of 50 ohms. What will the standing ratio of this system be? 4:1. The type of transmission line best suited to operating at a high standing wave ratio is 600 ohm open wire. Number 58. If an antenna is correctly matched to a transmitter, the length of transmission line will have no effect on the matching. Number 59. If the center impedance of a folded dipole is approximately 300 ohms and you are using RG8U 50 ohms coax lines, what is the ratio required to have the line and antenna matched? 6:1.